My name is Max, and today we're gonna answer the question, why are adolescents more risk-taking than adults? When we talk about adolescence, we mean the time frame of age from 10 to 20, so when you're a teenager. You probably have plenty of stories where you did risky, dangerous stuff as a teenager. Like, I don't know, riding downhill with a bike without a helmet between trees very fast. So now just imagine yourself standing at a cliff, and at the bottom of the cliff there's a lake, and with your teenage friends you're pushing each other and jumping down. Hey, do you want to jump down? Don't you dare to. And the chance of you actually jumping down there is a lot higher when there are peers around and when you have a teenage brain. Today we're going to examine why this is the case. So for that, we're going to jump in the brain development, the prefrontal cortex, and the reward system. So first, the brain development. In your brain, as you are born and even as a fetus, the brain makes new connections, the synapses between the neurons. And up to age 4, the number of synapses rapidly increases, as you can see, but then after age 6, it decreases again. But why is that? So just imagine neurons like cities, and you connect all the cities with pathways. And then after some time, you see which pathways are used the most. And these are the pathways, you make them bigger, and you make them easier to use. And the pathways that are not being used, you cut them down, you don't need them. And this is what happens after age of 4. And this is what happens in the entire brain. And these are influenced by mainly 5 factors, which is first, by the genes. So these are the construction plans for your entire body and also for neurons and synapses. And also by the fetal development. So when you were in the womb, what did your mom eat? Did she smoke cigarettes? Did she drink alcohol? Was she a lot stressed during pregnancy? And all this influences your entire life and your entire brain structure. Also, your brain structure is formed by epigenetics, which means your environment and therefore your environment changing your genes. And this means not changing the means, I mean turning on and off genes. We want to be clear here. So this means your social environment, what nutritions you eat, and this all affects your brain development as well. And also how your parents raised you, with the kind of values you learned, the morals. And also, addition to that, your experience, what yourself experienced, where you have been, and what your memories tell you. And this is actually the most important part for today's video. So the last brain area to evolve is the prefrontal cortex. Actually, frontal cortex, but we talk about the prefrontal cortex especially today. And this has some very, very good reasons for that. We'll come to that. So what does the prefrontal cortex do? And the prefrontal cortex, we can see, is subdivided into some parts, as the dorsolateral prefrontal cortex, so at the top, is there to do rational decision making. Which laptop to buy? Which way shall I go to school? Which way is faster? It is rational decision making. And the ventrolateral prefrontal cortex is for reappraisal and emotional regulation. So it rethinks stuff. It rethinks what you have done, what others have done, and evaluates these. So the prefrontal cortex, you can say, is involved in heavy thinking and mostly irrational stuff and telling yourself, come on, he's just being dumb, it's not that bad. And then it calms you down. But usually the prefrontal cortex sets in a little bit later than the emergent emotional feeling that comes up when you're being insulted, for example, and then it calms down. So next we come to the reward system. And the reward system, we look at the dopaminergic pathway. Dopamine is the neurotransmitter that gets released when you experience a reward, when something feels really, really good, as winning a game, and then you want to play more because it feels so great. You ate a little bit of chocolate, and then you want to eat more. It's dopamine flushing your brain. And this is produced in the ventral tegmental area, which is down here, the blue dot. And then it projects into the brain. And important now is the mesolimbic pathway, because with that, the VTA, the ventral tegmental area, projects to the nucleus accumbens, which is in the ventral striatum. And the nucleus accumbens is said to be the pleasure center of the brain. So whenever there's lots of good feelings about, oh, you won a fantastic, your dream car, your dream house, and then it's the nucleus accumbens that is very, very active. So, and then you can see the entire pathway. And what happens in adolescence is, well, we have a delayed maturation of the prefrontal cortex, and it develops roughly until mid-20s even. So there's a huge time frame where the rest of the brain is pretty much developed, but the prefrontal cortex is a little bit behind. So this means that they experience rewards completely different as adults or children. This means they are more excited for rewards when they're greater. They're much more excited, but when they're less big than expected, the reward, then they're even negative emotions. Yeah. So this is a huge difference compared to other ages. Also, they have social pressure, which means they worry about, what do they think about me? I want to fit in. Why am I being excluded? There's no prefrontal cortex jumping in and saying, hey, it's just a dumb game, don't worry about it. And this also means that there's a study where they did virtual driving, and when adolescents drove and their new peers were watching, they did lots more risky decisions and even did more car crashes other than adults. So, and you can see that they did twice as many risky decisions as they would do when they were alone. So it shows the delayed maturation of the prefrontal cortex in adolescence very well. So, but why does this happen? The prefrontal cortex, therefore, is shaped by experience and not by genes, which means we humans are a lot more adaptable to the environment, and this is one part why the human is so successful on Earth, because it can adapt very, very well. And this is partly due to the prefrontal cortex being developed so late. And this, well, I'm finished. So this might explain why the impulsiveness of adolescents for parents might be helpful to know. And addition with the hormone cocktail, there's a lot going on here. Yeah, so I guess we now could better understand the emotional outbursts of adolescents. And thank you very much, and see you next time. Bye.